Hi, welcome back to the Astrophotography Playground. I'm Jason. I'm looking forward to showing you around. I heard a rumor that you may be in the market for a new telescope or camera. Let's use the Astrophotography Playground to look at just 4 of the parameters that you should consider when doing so. For this example, I'm going to choose a galaxy, the triangulum, and I'm going to be using a narrowband filter. First parameter to be considered is telescope focal length. As we already know, the longer your focal length, the closer you get to the action. Second parameter to consider, camera sensor diagonal. Now, this may not be immediately obvious when you purchase a camera, but you can always look at the user manual or datasheet to find out how large that sensor is. The larger it is, the more field of view you get. Now, you may think at this point, wait, that's the opposite of zoom. Why don't I just go with a short focal length and small camera sensor diagonal? Wouldn't that be just as good? Well, it gives you the same field of view, but that smaller sensor does not give you as much ability to digitally zoom after the fact, nor does the combination of small camera and sensor give you as much light sensitivity as a large sensor and large telescope, rather. So we are going to go with this right here. That looks great. So we've covered 2 of the parameters, focal length and sensor size. This is a very dark image. There's not much to look at here. Let me increase my exposure time and also my ISO. Wow, this will be a challenging target. We knew that going into it because this only has a relative brightness of 0.03, so this is very dim. Which leads into our third parameter that we should consider, and that is focal ratio of our telescope. This is simply the ratio of focal length to diameter. As you go lower in F number, the corresponding aperture of the telescope gets larger, so it's a physically larger telescope, but that means it has more ability to collect light, therefore the image gets brighter. So you need less exposure time for the same brightness on a so-called fast telescope with low focal ratio. If I go back to f10, which is very common, we can see that the image is extremely dark. So let me increase ISO to see what is going on here. And in the past, we've been able to improve our images through averaging. So we try that here, and you know, the impact is ever so slight. In fact, this might be a little bit surprising. Why doesn't averaging make our noise go down and improve our image? The reason is we've already started with a very dim target. Then we've added a narrowband filter, which removes the majority of the light. All that's left now is a specific form of camera noise called dark current. And dark current is related directly to the camera temperature. So how do we fix that? We make the camera cooler. So for example, if we move from room temperature at 20 C down to even just below 15 C, image gets substantially better. And then as we continue to go down in temperature, the image improves. How do you cool a camera? You don't always have the option of doing photography from a cold climate. You have 2 options. One, you could get a camera that has the ability to be cooled, such as many astronomy cameras have this ability, whereas a standard DSLR camera almost certainly does not. Your second option, even if you can't cool the camera, you can take what's called dark frames, where at the exact same temperature, you take and exposure time, you take pictures in the dark, and you subtract those from your light frames. Those results aren't as good as cooling the camera. In fact, it's very likely that you'll want to use both methods to get the best results. Now that we have cooled the camera, we can go to longer exposure time and even more ISO, and we can see that the image certainly has potential to meet our expectations. If I then, just to wrap this up, go into image enhancement very quickly, we've already covered the 4 parameters that are important to us. Right now, we're just playing with the image just for fun. And that is we increase brightness, We remove gradients, give it a little bit more brightness, maybe some saturation to really, we want to see more of the color, especially the red. And yeah, we can see that nebulosity really clearly now. I hope this has been a useful lesson. Until next time.